Hello, welcome to the contest work by Northeast Normal University team in VAST Challenge 2019. In order to solve the problems of Mini Challenge 2, we design and implement an integrated visual analytics system, which contains 6 coordinated views. The trajectory view shows dynamic variations of sensor radiation values. The moving trajectories of mobile sensors are highlighted and the moving process is displayed by animation. The temporal variation view shows the temporal changes of the radiation values of the sensors in a specified grid area. The sensor matrix view displays the sensor's hourly average of radiation values. Each row represents a sensor and each column represents 1 hour. Colors encode different levels of the average radiation values. The vertical ordering is based on the similarity of the sensors, which is consistent with the sensor projection view. For describing the uncertainty of sensors, we design the sensor projection view and the grid summarization view. They draw the uncertainty embedded glyph for each sensor and grid, respectively, which describes the corresponding mean, the standard deviation, and the monitoring frequency. After selecting a glyph, it can be extended in the detail inspection view, where the outer ring represents the standard deviation per hour. The second ring uses color to show the hourly average, and the radial bar chart in the third layer shows the hourly monitoring frequency. The scatter plots in the fourth layer display the distribution of raw data for each hour, where the colors encode the point densities. The system provides abundant interactions for users to explore the data freely. For helping new users to get started quickly, we suggest an analyzing process as follows. First, it can be observed in the sensor matrix view that some sensors began to monitor continuous high radiation since 10 a.m. on April 8. So we infer that the first earthquake occurred close to this time period. Then, we select this time interval, and it can be found in the trajectory view that the high values are mainly concentrated in the several grids around the nuclear plant. At the same time, the trajectory view supports the selection of the place speed, the sensor and the time period to facilitate the detailed exploration. Finally, we select one of the grids, and the sensors in this area generally maintain relatively high values as shown in the temporal variation view. So, we eliminate the doubt of sensor failures, and determine that nuclear contamination has spread to several surrounding grids. Then, we focus on the extended glyph in the detail inspection view. It can be observed that there is a sharp increase in mean and uncertainty after 10 a.m. on April 8, which can further verify our judgment of the occurrence time of the earthquake. In addition, there is also a sharp increase around 3 p.m. on April 9. Thus, we infer that an aftershock happened around this moment. Moreover, we find an interesting phenomenon through our system, as shown in the sensor matrix view. A special pattern can be recognized that 2 groups of mobile sensors lost the monitoring values on the morning of April 9, and one of them then presents high radiation values while the other presents relatively low radiation values. Thus, we select this pattern and view the animation in trajectory view. It can be found that 2 groups of mobile sensors left the island from Wilson Forest Highway and Jade Bridge in the morning of April 9 and come back at night. Then, the group returning from the bridge presents relatively high radiation, while the other group returning from the highway presents extremely high radiation. It can be inferred that the highway is blocked due to traffic control, and these cars were placed at the highway entrance. According to the sensor ID, these groups correspond to the group A in the sensor projection view. Then, we select a sensor, and it can be observed in the detail inspection view that the radiation value of about 1500 cmP and the high uncertainty are maintained on the evening of April 9. It can be determined that the area around the highway entrance is also heavily polluted. In grid summarization view, it can be observed that the southeast half of the island lacks adequate monitoring, especially in the grid where the nuclear plant is located. The monitoring time coverage is less than 30%. Since it is the most important area needed to be monitored, it is necessary to deploy some static sensors in this area.